This is the Guns Magazine podcast, episode number 66. Hi there, and welcome to the Guns Magazine podcast. I'm your host and the editor of Guns Magazine, Brent T. Thanks for joining us as we talk to the interesting people who make up the world of shooting, hunting, and the firearms industry. First off, before we get started, let's talk about a new sponsor, Berger Bullets. Berger builds match-grade rifle bullets and ammunition for target, hunting, and tactical shooting applications. Proudly made in Mesa, Arizona, Berger uses the highest quality materials, tooling, and production processes to produce the world's most accurate bullets and ammunition. Berger is unequaled by the competition and has established more long-range world records than all the other manufacturers combined. To find out why our nation's elite operators, competitive shooters, and hunters all trust Berger to shoot better, visit your favorite retailer to experience Berger's uncompromising quality or learn more at BergerBullets.com. Well, today I'll admit I'm completely outgunned because I'm talking with two of the most knowledgeable people in the world about long-range shooting. In this episode, which I'm calling Long Range Grad School, I talk with Bryan Litz, the famed author of the book Applied Ballistics for Long-Range Shooting. Bryan's also a world-class rifle competitor and happens to be the chief ballistician at Berger Bullets. He is considered the expert on what happens to a bullet in flight, and even though he's smarter than a squadron of magazine editors, he can actually explain these concepts so even gun writers can understand them. Joining Bryan is Emil Praslick, a guy who's been called the king of the wind call. He's the former head coach of the U.S. Army shooting team, holder of 20 long-distance shooting records, and probably the number one guy you want standing next to you with a spotting scope. Now buckle in for a graduate course in long-range shooting with Bryan Litz and Emil Praslick. Good afternoon, gentlemen.
Good afternoon.
Hi, Brent.
Well, let me throw this out to the floor first off. Ballistics are one of the most misunderstood things in life, yet so many folks are really quick to offer up advice as an indisputable fact rather than their own wild-ass guess. Do you guys think that with the internet and this renewed focus on long-range shooting and a lot more technology and better guns and cartridges, do you think people understand ballistics better than they did, or you still think there's just so much behind the curtain that people don't get?
In my opinion, I think there's the potential to understand ballistics is greater than it's ever been. But as you mentioned, with the internet and the misinformation, the potential to misunderstand ballistics is also as great as it's ever been. So I think it really comes down to the individual, and this goes beyond shooting. This is anything really that you want to learn about. It comes down to the individual doing the searching and how they do their search. Critical thinking, all that stuff is the same regardless if you're studying ballistics or electronics or whatever it is. You just have to find some trusted, credible sources of information and, avoid the less credible sources. And I think you'll be fine. I mean, there is a ton of information out there. And to be honest, you preface this as sort of a graduate course or talking about the numbers. It doesn't have to be as intimidating as you might think. I think when some people talk about it, it almost seems like their objective is to make it sound more complicated than it is so that they can kind of have a unique grasp on it. But I've always taken the other approach, which is to kind of take the complex ideas, if they are complex, and boil them down into layman's terms and sort of be that bridge between the science and engineering side and what the average shooter needs to know to hit targets. And not all of it is really all that complicated, to be honest.
Well, that's very good to hear. So before we get into that, let's drill down, though. Your book, Applied Ballistics for Long-Range Shooting, is considered one of the foundational books in modern ballistics. Why did you want to write that? And more importantly, how do you think this has impacted our greater shooting world?
Well, that book, we're in the third edition of that book now, and it still contains basically the same information. It's just updated and some things have come and gone. But the goal with that book was not really to break new ground. The goal of that book, I think it was 2009 it came out. The goal of that book was really just to take a lot of those concepts that are important for shooters to know about, like spin drift, how wind deflection works, how Coriolis effect works, basic statistics for hand loading, things like that, and communicate them in a way that everyone can understand. So this is knowledge that has existed since the World Wars. World War I and World War II, the countries of the world figured out a lot about small arms unguided ballistics, and that stuff sat on dusty library shelves and old textbooks for decades. And there's people who most people didn't realize that what the state of the art was in the science. They'd go to a rifle match and talk to the guys at the pits and think that was the extent of the knowledge available to the world. And the reality is there's a lot of great scientific knowledge that was just kind of locked away in those dusty tomes that it takes an engineering degree to really dissect. And so my goal with that first book was to just be a bridge between the average shooter and that information that's already known. We can at least start by communicating the state of the art to the masses that need to know it. And then after that first book, we actually did start into breaking some ground on some things that weren't tested before, or maybe doing the same type of test, but with modern equipment. It's just starting to actually contribute some original information, such as all of the ballistic coefficients that we've measured for all the bullets. Used to be, you get a BC from each manufacturer, and they could be very biased because it's used for marketing and such. And so one of the first original contributions that I would say came through my books was the unbiased third-party common approach to measuring BCs across all the brands. So that kind of is how I look at the origination and then progression of the books. Is started out just talking about what people already knew, and then got into breaking ground.
And just for definition purposes, in case folks don't understand, and you can correct me if I'm wrong, I think I at least know this much. If we're talking internal ballistics, that's the part where a bullet is in the gun, and that's not what we talk about here. Or terminal ballistics, which is once a bullet reaches a target, such as a game animal or a bad human being. We're talking about external ballistics, which is from the time it leaves the muzzle until that bullet impacts. And am I correct before we go further?
Yeah, that's the external ballistics is mostly what we're talking about here, the free flight portion.
And I was just going to say, Brent, that as a shooter, so when Bryan's book first came out in 2009, I was in the competitive shooting world, shooting for the Army, and when his book came out, it really was such an unbelievably groundbreaking piece of work, because it really put into terms that shooters can understand what these concepts were, and how to kind of sort the wheat from the chaff with respect to what ballistic coefficient is, how it's measured. And Bryan really took a unique approach. His origin story, kind of like his comic book origin story, is really interesting, because Bryan developed ways to test these things as like, hey, I'm just like a regular dude without $1 million laboratory. So how do I test ballistic coefficient? So he figured it out by using like microphones and really, really ingenious ways of getting these numbers. And then by doing that, he was able to like kind of dispel a lot of misconceptions that people had. And for me, a guy that didn't really know a lot about ballistics, I knew how to shoot, I knew a little bit about how to read the wind, but understanding about the relationships between velocity and ballistic coefficient and drag and all these concepts. That's why like his book is on the shelf of, you walk into any team room in any special operations sniper cell, and that book is on the shelf. And that's the reason. So I would highly recommend people pick up that book. I don't get a dime. So
and I totally agree. So you actually skipped ahead of my list of questions here. So let's walk through this process of gathering data. I mean, how do you gather scientifically valid information about something that happens literally that quick?
Yeah, so the principles of measurement are pretty easy to understand. It really is a case where the devil's in the details. So in this particular case, we're talking about ballistic coefficient. Okay, how do you measure ballistic coefficient? Well, you got to know what it is to measure it. So the ballistic coefficient is basically a bullet's ability to retain velocity. Okay, if you've got a high BC bullet and it comes screaming out of the barrel, it's still going to be screaming through the air at 300 and 500 yards. A low BC bullet may have the same muzzle velocity, but will lose that velocity a lot faster. I mean, think about throwing a baseball versus a ping pong ball. Okay, you throw them equally hard, and by the time each one has gone, 50 feet, the baseball is retaining a lot more velocity than the ping pong ball, if it even goes 50 feet, because it has a higher BC. Okay, and that's what we're talking about with bullets. But because they're all, pretty much lead core, it's hard to think of them as like a baseball and a ping pong ball. They're all, but that's basically what it is. And BC is made of several components. You've got the mass, how heavy it is, how big around it is in diameter, so the caliber, and then you've got the shape of it. So is it a very blunt shape with a flat base, or is it a long spitzer nose with a boat tail? So between those things, that's what makes up that bullet's ability to retain velocity. And then all of your performance metrics come out of that. A shooter might hear, retain velocity and think, well, okay, that's relevant for retained energy, but what else really? And the answer is everything else. Wind deflection is determined by how well your bullet retains velocity. Drop is determined by how well your bullet retains velocity. All of the uncertainties in your environment, like range uncertainty, temperature, pressure, humidity uncertainty, all those uncertainties get absorbed and result in less miss distance when you're shooting bullets with higher BCs. So it's very important to know what your BC is so that you can map the performance of your round, as well as predict the trajectory of the bullet. If you're trying to hit a target at 1,000, 1,200 meters, and you've got a 0 at 100, well, that's a lot of distance that thing's flying unguided that you've got to correct from your 100-yard 0 to be able to hit a target that far away. And if you miss the BC by a couple percent, then your fire solution is not going to be accurate enough to hit a target. So that's what BC is and why it's important. Now, how to measure it. So when you understand what it is, okay, it's a measure of how well a bullet retains velocity. So the most obvious way that you could think of to measure BC would be to measure the velocity at the muzzle and then measure the velocity downrange and do a direct, that is directly measuring BC because that's how well it's retaining velocity. Another way that you could do it is to measure the muzzle velocity and then the time of flight to a distant target. And in that case, you time of flight is like the integrated result of velocity decay. And so you can mathematically get BC that way. Another way that you could do it that's even less direct would be to measure your muzzle velocity and then your drop at long distance. So let's say you're 0'd at 100, your muzzle velocity in the atmospherics, and you know that you've got 28.5 minutes of angle drop at whatever distance. Now, in terms of first principles in measurement, your most reliable methods are going to be the most direct methods. So that measuring velocity decay directly is your most direct way. Now, talk about this practically. Back before I had a budget or a staff or a laboratory, the only way you could really measure velocity at 2 points was with 2 chronographs and, the typical light screen chronographs, the Ehlers and things like that. And you're kind of limited on range. You've got to thread the needle with that downrange velocity measurement. And so the practical application of that really limits you to about 300 yards. When you're testing dozens and hundreds of different bullets, to shoot them all through a chronograph at 300 is, it's manageable, but it's kind of difficult. I'm sure everybody's got a pet load that maybe they could shoot through a chronograph at 500 yards with. But when you're testing many, many things, you need a robust test method. And there was a period of time where we did use 2 chronographs 300 yards apart to measure BCs. The method that is most versatile, at least short of Doppler radar, within, you can make these systems for not much cost, or even the Ehlers acoustic systems work this way, is by measuring time of flight. And the idea here is you still have to measure your muzzle velocity, but now you can have an omnidirectional microphone downrange where if you've ever been downrange, like in the pits of a rifle competition, that bullet is loud going overhead. You need ear protection. It's how loud it is. And that crack, if the bullet's supersonic, makes a very crisp signature to measure the time that it arrived at the distance. And by using your measured muzzle velocity, atmospherics, and that time of flight, you can calculate ballistic coefficients. Now, you can calculate them within a certain area. Oh, the thing that makes time of flight measurement easy at long range is you don't have to shoot through a window like on the chronograph. You get anywhere within 10 feet of the microphone and it's going to pick up that sound pretty easy. Now, I said the devil's in the details. One example of that is, you kind of have to know how far the bullet is passing from the microphone, because there is a time delay for that sonic shockwave to get from the bullet over to the mic. So if the bullet passed 1 inch from the microphone, that's going to make it seem like the time of flight was shorter than if the bullet passed 10 feet from it, and then it just took an amount of time. So those are the kind of things that you struggle with, and in 1 hour, you can mentally sketch up a design for how you're going to measure BC, but then you can spend the next month agonizing over the details of getting it right. But the good thing about science is there are indications that will tell you when you have it right. And repeatability is the hallmark really of scientific measurements. If you take a bullet out one day and you shoot it and measure, tear down your equipment, come out a day or week later or so, set it up, do another independent test. And when those two tests result in the same measurement of BC for that bullet, that's when your instruments and your procedures are giving you good results.
Okay, let me ask a dumb guy question then. When it goes subsonic, are you out of data points, or is there some other way?
There are ways to deal with subsonics if you're using acoustics. One way is to use an impact target. The Ailer systems, most people are familiar with like the Ailer 35P chronograph, wonderful piece of equipment. And they have a system 88 and they're going to have a system 89 soon that uses downrange acoustic targets to measure not just time of flight and BC, but also like it can plot your shots on a target because it uses multiple microphones. But what they have for measuring subsonics is an impact target. So they'll just, for example, a sheet of plywood, and the microphones are clamped onto the plywood, and it works the same way. Now, when the subsonic round hits the plywood, that shock propagates through the plywood to the microphones, just like it would if it was supersonic. So there are ways to deal with it there. These days, the instruments that we use are Doppler radar. And that doesn't really care how fast the bullet's going in relation to sonic. It's sending out a signal, bouncing off the back of the projectile, and the thing that's being measured there directly is the Doppler shift of the signal that's sent out. So you send out this frequency, you get a little different frequency back, and the signal processing tells you the speed of the object you're tracking. And so that's pretty much the only limits on Doppler radar is the distance, which is a matter of power, how powerful your radar is, what the field of view is. But with Doppler radar, you get data points. You could have a data point every inch if you wanted to for 2,000 yards. So you have very continuous data from the Doppler radar, but there is a practical maximum limit to it depending on the power.
Now, getting back to BC, playing the conspiracy theory guy, because you hear this, is the numbers published by the manufacturers, they don't really line up with the real world. And you can find variances where people calculate this BC as such, and the manufacturer says this. Why are those differences there?
Well, there's a number of reasons, and it used to be a lot worse. It used to be Wild West, I've measured errors in BC of marketed numbers compared to my numbers of 10, 15, 20% 10 years ago. But these days, the numbers being advertised are much closer to what we're getting experimentally. But there's still some differences, and they're not all malicious. I think the assumption when someone sees a BC advertised by a bullet company and it turns out to be a little high, I think the assumption is, well, they know they're inflating the BC for marketing and for sales. And that may be true in some cases, but there are technical reasons why that could happen too. One of them has to do with the velocity dependence of BC. So to understand that, we need to talk about one detail of BC, which is the standard that it's referenced to. Okay, most of the old BCs that you would see were referenced to the G1 standard. Okay, that's relates to a projectile that's a flat base, kind of a blunt nose, kind of like a black powder cartridge rifle bullet, which was kind of the state of the art back whenever the method of BCs was created. Now, what happened in the meantime is, we got smokeless powder, higher velocities, which means we got jacketed bullets. Now we got more streamlined bullets at higher velocities. And that G1 standard for BCs didn't really represent the state of the art anymore. And so there's other standards to choose from. One of them is G7. The G7 projectile looks more like a modern projectile. And whenever you reference your BC to a bullet that really looks like your bullet, what you get is a BC that is consistent from the muzzle all the way to the target. So whether the bullet's going 3,000 feet per second, 2,000 feet per second, or 1,500 feet a second, the BC doesn't change very much because you're using a representative standard to define it. Whereas the G1, you might see a 10 or 15% difference in the BC of a bullet just from the muzzle out to 1,000 yards, where it has slowed down. And so typically with the G1 standard, what you'll see is a bullet will have a higher BC when it's going fast near the muzzle. And then as it flies down range, the BC in relation to the G1 standard gets lower. So you see the BC go down. And like I said, with the G1, if you use the wrong standard, you may see your BC degrade as much as 10 or 15%. And that's a really hard thing to manage if you're trying to, what BC do I input if I'm trying to hit a long range target? Do I use the high velocity, the low velocity, or the average? You've got all this gray area. Well, if you're in the marketing and sales department and you see where a bullet was tested at short range and high velocity, you have a number that's technically a legitimate number to use. It's not a lie. But because it only really pertains to, say, the first 100 yards, it's not necessarily the best number to use for accurate predictions at long range. And so that's one of the many reasons how you could go wrong with a BC is by not properly regarding the velocity range or the standard that it was measured against.
So you hear the G1 and the G7, and there's a whole bunch in between. Are those pretty much the ones you want to concern yourself with?
Yeah, there's the others are not used very much. In the last 10 years, a number of bullet companies have started advertising G7 BCs as well as G1s, and the G7s are actually pretty good. I mean, we've not found anyone advertising G7 numbers that are egregiously different from our numbers. Maybe just like lot variation or a little outside of that, because that velocity dependence is not such a question mark with G7s.
So VLD bullets, is that marketing? What makes a VLD or very low drag bullet? Because they look kind of like a boat tail, spire point to me. What makes a VLD and why is that important?
Yep. So the very low drag design was created a long time ago. It's actually just a new name given to an old geometry. The geometry of bullet noses, you can think of them in terms of circular arcs. Okay, imagine you've got a great big circle and you take about 30 degrees of that circle. The arc that you have there, if you now flip that over on the axis to get two sides, that's basically what bullet noses are made of, is circular arcs. And there's two types of circular arcs that bullet noses are made from. One is referred to as tangent and the other is referred to as secant. And a tangent ogive is a name for the bullet nose, tangent nose, you can identify that because where the nose blends into the bearing surface is very gentle. Basically, that curve meets the bearing surface on that straight line. So if you're looking at a shiny bullet in the light, you can't really pinpoint where the nose meets the bearing surface because it's such a gradual blend there. On the other hand, if you've seen bullets like the VLDs, Those noses are made of longer radius circular arcs, and where the nose meets the bearing surface, instead of being tangent, that connection is secant. And that means it's just another way of saying there's a discontinuity there, which is very easy to see exactly where it is. And so what a VLD is a secant ogive with a particular radius that is a theoretical minimum drag shape for a bullet of a given nose length. So that's all a VLD is a particular variant of a secant bullet nose.
So are they better? Should I always seek out a VLD in my chosen caliber if there's one?
VLDs, because of the low drag of the nose, will maximize BC. The typical trade-off that you get with VLD bullets is you get your high BC. Okay, they're usually very high for the weight and caliber of bullet. But sometimes with VLDs, the precision or the groups you're going to shoot can be very sensitive to seating depth. Okay, you may find that you've got to seat the bullet out into the riflings in order to get good groups, which that's got its own set of problems, potentially bullets sticking in the throat if you try to eject a loaded round, or it may mean that you need a cartridge overall length that's longer than your magazine. And then if you were to seat that VLD back to magazine length, you may not get very good groups there. You might, but you might not. I'll put it this way. If you're exploring the range of seating depths for a VLD, you might shoot groups that go from a quarter minute all the way to a minute and a half. Okay, there's a great range of potential group sizes just based on seating depth with VLD. So that's the downside. Now, go to the other bullet type, the tangent nose, and those pros and cons are reversed. The tangent nose is not the lowest drag shape, so it won't have the highest BC usually. However, it's a very sensitive, very insensitive shape to seating depth. So you can seat it near the riflings, you can seat it at magazine length, you can seat it anywhere in between. And, you know, its range of groups, instead of going from a quarter minute to a minute and a half, you know, if a quarter minute is still the best, your worst might be half minute. Okay. Just to say the concept of we say that they're more length tolerant. So seat them to any length and you're not going to really shoot terrible groups.
Yeah.
So that's kind of the trade-off. It's not all about BC. The bullet has to work for you in the gun too, in terms of mechanics and precision.
Well, let's get out into the field a little bit, and I'll throw out a discussion question for the forum. And this is completely an opinion question, but with your knowledge, both you guys' knowledge of ballistics, so is the 6.5 Creedmoor the king of the hill, sub 1,000, or is there another, 6.5 PRC, or what's your thoughts? Because the Creedmoor certainly is popular in long-range shooting. Is that the end-all be-all, or what are your thoughts?
I think it really depends on a person's application, Brent, and kind of what their resources are and what their application is. They're like a 300 PRC or a 6.5 Creedmoor or a 308 Winchester or a 338 Lapua Magnum. They're all excellent candidates for different things, but some have different barrel life expectations. You have the access to commercial ammunition. You have access to production rifles. So I think for a person, and for aftermarket barrels, things like that. So if a person's choices and choices should be kind of made on, like, usually it's a compromise, so if a 6.5 Creedmoor is a great caliber because it offers a lot of good compromises. It has average sort of barrel life, not as good as 308, but not as short a barrel life as some of your high powder capacity Magnum cartridges. It offers good ballistics because, as Bryan said earlier, with these longer bullets, magazine length is a real limiter for the size and the ballistic coefficient of bullet you can put in a particular cartridge. If you have if you're limited to standard magazine length like 2.80 or 2.810, which is CIP SAMI mag length for 6.5 Creedmoor, that same cartridge, like in like a 260, you can't put the heavier caliber bullets like 140 grain and higher in that 260 and maintain magazine length. But in a 6.5 Creedmoor, because of the design of the cartridge, a little bit of a shorter cartridge, a little bit of a sharper shoulder, a shorter powder column, that lets you put those long bullets in there. So it's a person's application and all those other considerations, I think, will drive what they think is a good caliber for long range shooting. 6.5 Creedmoor is an excellent candidate. I know a lot of people give the caliber a lot of grief on the internet, mainly because, you know, the mass popularity of it. Again, you have a lot of people coming to the long range game without a lot of technical knowledge or background, and they've got a buddy who told them something, right? And so that buddy tells him something, and that guy goes and repeats it. And man, his friend is a great shot, and he told it to him, so he believes it. And so there's a bit of a bad rap, especially among the older crowd, that 6.5 Creedmoor is relatively a newcomer to. So nothing is as good as my 308 or my 30-06, those guys. But for, you know, certainly 1,000 yards and beyond, the 6.5 Creedmoor has the capability for that bullet to remain supersonic past 1,000 yards, depending on barrel length and everything else, which is, you know, it's a reason why the military, special operations, they've pivoted to 6.5 Creedmoor over .308 Winchester for that sort of intermediate range caliber sort of sniper support rifle. So it is a great caliber. And 300 PRC is great, but again, you've got those barrel length issues. You have to have a Magnum bolt face. You have to have a Magnum size rifle. Factory ammo is probably a bit scarcer. It's more expensive, etc.
Well, it's great hearing the experts say what we've tried to say all along, is your mileage may vary. There is no one perfect gun, cartridge, shooter, piece of equipment.
You know, my father always said, beware of the man with one rifle.
Exactly.
So whatever you have, learn to shoot it well, and it will serve you.
One thing I wanted to cover that's fascinated me is let me read this here. You are widely recognized as one of the greatest wind wizards on the planet. That's pretty high accolades there. And for folks that aren't into the long-range shooting game, the spotter, coach, whatever term you want to use, the guy or gal that's standing over the shoulder of the shooter and calling the wind is as critical as the loose nut behind the gun. So you've obviously, I'm not going to go down your incredible list of accolades doing that, but what is it about wind that seems to click with your very soul?
Well, first, that's very generous of you to say. I could probably name 10 guys off the top of my head that I've worked with all the time, and that could easily on any given day smoke check me on a range. Just saying that up front. So when I was in the Army, I was at the Army Marksmanship Unit, and I was the head coach there. And so like my quick little story time is when I first came on the Army team as a shooter, we were at a long range match out of 29 Palms in California, and the wind was just hooking. And, you know, I asked one of these old timers on the team, well, how much wind do you think is down there, Sergeant? And he looked down there, kind of squinted down there, and he's like, that's about 11 and a half minutes. I'm like, okay, well, how'd you know that? He goes, I don't know, it just is. I'm like, well, what do you mean? He goes, well, it just looks like it's 11 and a half minutes. You know, one of these guys that had been doing it forever and could, like, you know, his brain is some sort of algorithm with like observation of physical effects or what the mirage looked like or what a wind flag or what the trees were doing or the grass or whatever. And I'm like, man, how do I learn how to do that? And he's like, man, it takes years. You know, maybe in 10 years you'll get it. I'm like, well, I don't have 10 years, brother. Like, I want to know it like right meow. So I kind of like, you know, I kind of just started collating all these different sort of wind techniques and everything to where, like, how do I put a number on something quickly? And a lot of it has to do with a lot of the stuff, honestly, that I learned from Bryan about, again, these sort of myths, these sort of tribal stories that get passed down, you know, like the not to turn this into a wind reading clinic, but like the perfect example of where myth doesn't equate to science is if you've been on a range and the wind's coming from about your 45 degrees or 130. And a guy is looking down range and he goes, well, that wind's coming from right around 1:30, 2 o'clock. That's a half value wind. And intuitively, you would think that because, 12 o'clock wind or in your face is no value, no left or right significant effect. And the full effect of the wind is at 90 degrees or say 3 o'clock. So intuitively, you'd think, well, 45 degrees is halfway between 12 and 3. It must be half the value of the wind. So I would, whatever my, data sheet or whatever it is tells me the wind effect is, I'll cut it in half and I should be good. No, you've just missed the wind by 20%. So that's why most new shooters miss downwind, because if you get into the science and the technical stuff with wind reading is you start learning about what does the percentage of the wind relative to the angle. And it turns out a 130 wind or 45 degrees is really about 71% of a full value wind, not 50%. So right off Jump Street, you've missed by 21% of the wind. And at high velocities and at long range, that's a miss on just about anything you're shooting at. So I started out life as like my first job in the Army was like I was a machine gunner, assistant gunner. So doing range cards and all that stuff you did as a private. And I just kind of applied that same thing to the wind. And I started looking at, okay, how do I figure out the direction? How do I figure out the velocity? Then how do I figure out what that net effect is on my bullet? And you pair that with ballistic solutions that are out there now that will tell you if you have accurate inputs like the accurate BC and accurate inputs with atmospherics, which these devices like the Kestrel and lots of devices now have like integrated ballistic solvers like Bryan's applied ballistic solver has been integrated in lots of devices that you start putting together all this information, you get a really good picture of what's happening downrange, and that will give you the effect at range of your bullet. Now, you still have to do the manual work of knowing how fast the wind is blowing and which direction the wind is. But if you can figure out those two things, you can figure out the net crosswind effect of whatever it is. If it's a 10-mile-an-hour wind and it's coming from that 130, well, then it's worth about 7 miles per hour, a true crosswind effect. Once you know that, you can then use all your resources and figure out how to put steel on steel. And that's the undercarriage of my process. And then, there's sort of tactics, techniques, and procedures, and there's things about how to learn about looking downrange and understanding how the wind, which part of the range, depending upon your application, affects your wind solution the most. If it's a short range, medium range, or long range engagement, does different thirds or halves of the range with the similar wind conditions make a difference in wind and terrain? Shooting in different conditions, you sort of build this Rolodex of experience. And obviously I have a little bit of an affinity for it. I literally can't remember where my wallet is downstairs in the kitchen, but I can tell you probably about every range I've shot in over my career, what the range looked like, which way the wind was blowing, and kind of how much wind I was using on a given day.
Yeah.
It just sticks in my brain. And it's habits. You build habits. Like, what's the wind speeds? Like when I walk out of the grocery store, I'm looking at the tops of the trees. I'm trying to look at the mirage on like the hoods and roofs of cars. And I'm always trying to put a number on the wind. And you inculcate those habits and those best practices. And pretty soon it turns into a party trick of you knowing what the wind speed is, and you can directly input that into a solution.
Yeah.
And that's it. Now you know exactly as much as I do about it.
Yeah. I'm always, truly, that of all the long range shooting stuff, to me, that's the most voodoo, woo kind of stuff, is a guy that can look down range and pick 2 or 3 different wind calls on that range. I've shot out at FTW Ranch in Texas, and they're noted for a lot of times you're shooting from the tops of canyons down to the bottom. And especially the instructors out there. Of course, they work in it every day, but they're like, okay, you got a full value wind there and you got a half there, and this one's coming straight up the draw. And it's just amazing to me.
Well, it's like that old Isaac Asimov quote, when any technology is sufficiently advanced, it looks like magic. If you don't know what the guy's doing behind the curtain, it looks like magic. But, and that's kind of been my goal. My whole career is trying to demystify reading the wind and give a guy a solution set, give him like, what do I have to do physically to put a number on it? And if you just break it down by those numbers, figure out the speed, figure out the direction, and figure out the bullet's effect, you could put it as close as anybody. You'd be surprised how similar people are, even really inexperienced people looking downrange and be able to put a number on just wind speed. And those guys at FTW Ranch, I've shot out there too. And when you get that kind of complicated terrain of shooting across terrain features and draws and valleys and things like that. But again, that's just kind of a basic understanding of how the wind moves in those terrains. And once it gets sort of demystified, a guy tells you what's happening, looking about the wind as water going through these certain channels. Again, this veil is lifted from your eyes. So it's not as hard as people think it is. And what I don't want people to learn how to do, what I think you should not aspire to be, is the person that old sergeant is, chomping on a cigar, looking downrange, and it just looks like a certain wind condition. If you can't tell the person why it is, then like your ability as an instructor is compromised, and that person can't take that and pass it along.
If I can make a comment there to follow on, I think one of the reasons that effectively managing the wind seems like magic or out of reach for newer shooters in particular is because it's very difficult to observe and to learn the cause-effect relationships in the wind if you're still struggling with anything else fundamental about your equipment. If you don't know what to expect from you as a shooter and your equipment in terms of group size at 1,000 yards, or if you haven't done a tall target test to verify that your level is correct on the gun, back up a step, you better have a level on your gun if you're going to be reading wind. There's a lot of things that you have to do to get to the point where the wind is the last remaining variable. Everything else up until that point, it may not seem like it to a new shooter, but everything else is really figure outable. It's deterministic. But the wind is something that's different day to day, different shot to shot. And these pro shooters who have mastered all the fundamentals, they don't have to worry if they have enough rounds for the match. They're not wondering what their zero is on the gun. Like, they know they can lay down in a no wind condition and shoot an X one after another if the wind doesn't blow. So the only real challenge for a shooter like that on any given day is staying on top of the wind. And whenever you spend time as a coach, it's even more now all of your headspace is dedicated to just the wind, because you literally aren't thinking about shooting mechanics at all. It's you and the wind, and you're just telling the shooter, where to aim in the wind. And so whenever you can free up your thinking from all of the, laundry lists of tasks it takes to execute a centered shot and only focus on the wind, these things start to become more evident. When you're new and you don't quite yet know how big of a group you should expect to shoot, or nothing's really in perspective, it's very difficult to get your head around the wind, not because the concepts are hard, but because it's hard to see that cause-effect relationship until you're really dialed in.
Getting off on technology for a second here, there's at least one commercial device right now that measures what I've, heard called the last unknown variable, and that's wind, because you can measure it at your firing point and you can observe it, but you can't measure it. And now there's a Doppler device that measures different wind velocities, and I got to play around with it at FTW. Do you guys see the technology as eventually getting good enough and being downsized enough that it'll be like ballistic calculators that we have laying on the mat with us, unlike 20 years ago when I had my charts and graphs in my little book?
That's really a question of technology maturation and becoming economized. Like, that technology exists. They have LiDAR, they have systems for avionics for like landing helicopters on, carrier decks and high crosswinds. Like the technology to measure wind in range gated segments exists. It's just incredibly heavy and incredibly expensive. The people that invest millions of dollars in wind farms, they know how the wind blows there, every inch of it. Likewise, the avionics scenario, but to miniaturize it to be useful to a shooter and, batteries and all that, and to be, long enough distance, that's what the state of the art is progressing towards now, and it's been an ongoing development. Like you said, you've had one of the first commercially available devices, and I think it only goes to 300 yards. And I think it's a good example of a first prototype in the commercial space, but to answer your question, I think it's going to get better. But even the methods for measuring wind are stochastic because it's a fluid. Wind is not like gravity. It's not like time. It's not like distance. Wind is a fluid. There's a gradient of wind field between you and your target that's changing constantly. So even with perfect measurement, supposing you could have perfect measurement, from the time you decide what your wind hold is going to be until your bullet actually flies through all that air, the wind is in motion. It's changing. So I don't think we'll ever be able to determine it as accurately as we do gravity and distance with laser rangefinders and atmospherics, such as temperature, pressure, and humidity. But I do think the technology will get better, and I think it will take a lot of the guesswork out.
Yeah, I agree completely. But you've got also, truly mature technology. A device would have the ability to read the wind and have some sort of, even like an assistant, sort of an AI in it as well, that would be basing upon the size of your target, the expectation of the wind to vary given the previous history that it's seeing, and then be able to sort of say, okay, there's a certain percentage of chance that the wind is going to be stable long enough for your time of flight, and it'll give you maybe a carrot like a fighter pilot would get and lock in on it. That's a completely fully mature, prototype of a device. Getting there and getting it to cost less than $25 or $50 or $150,000, so it's within reach to the average shooter, that's going to take some work.
Well, it's hard to predict where technology is going. It's just, crazy the things that people come up with now. But let's get back to the ballistic side of it. Lead and copper and steel. What do you guys see? What is the new frontier? What's going to happen in 2 years or 5 years? Or, every year I think we've matured bullets about as much as we can. Is that true?
Not as much as we can, but we definitely have seen a progression towards longer bullets that are heavier for caliber. We've got bullets over 150 grains for 6.5. It used to be 140 was the top end, and even that was a quite heavy for caliber bullet. And where that limit was set, I think was due to the balance of the bullet and the precision that barrels could be made to. If you spin something, the faster you spin something, the more dispersion you get if there's imbalance and problems with it. And because modern manufacturing techniques allow us to make better balanced bullets and better centered chambers and all that, that has allowed us to progress to faster twist rates to stabilize longer bullets and retain the same or better precision. So that trend, there's no reason that would slow down or stop. To take a quantum leap into, small arm technology, we'd be looking at sabos or fin stabilized sabo projectiles like they shoot out of tanks. There's no scientific reason why that can't work for small arms. It's just that it hasn't been fully explored and developed yet. I know it's difficult to scale down the same stuff they're using in tanks, because when you scale that kind of stuff down, the relative muzzle energy to your projectile mass is not favorable for scaling down to smaller calibers. The muzzle blast from a tank is enormous, but because that sabo projectile is so massive, it doesn't really disturb it much in flight. But you look at the muzzle blast versus a sabo for 50 cal or 6.5 millimeter dart, and that disturbance is much greater proportionally and gives you a lot more dispersion. So there are challenges, but there's nothing fundamental that says we can't go there. I think that in terms of effect, the improved effects that we're going to see in the near future, and I shoot ELR matches, Emil and I do on a team, and targets out to 2 miles, sometimes even further. And I don't think we're really going to see farther target engagements, because there's already people shooting at targets 3 and 4 miles away. But I think what we're going to see is increased hit percentage on those targets that are, at 1 mile, mile and a half, 2 miles. When ELR started as a sport, 1 mile target was a pretty difficult, it wasn't a gimme, but now, like, if you're not hitting the mile target every time, you're not really in contention. And to me, that's my measure of progress is, we're able to have a higher hit percentage on those targets. I mean, it hasn't taken many years for the typical long range shot to go from 1,000 yards. For decades. It's 1,000-yard shot. That's a long ways. Now it's within a short time that's moved to a mile. Like, there's people hitting targets at a mile with 6.5 Creedmoors, a common round equipment that you can get from a good gun store. The gun, the ammo, the scope, everything it takes to go out and start hitting targets at a mile. That's a lot of advancement, I think. And that's where I think it's going to continue to go, is to increase the hit percentage on those targets that we can already reach.
Yeah, and cartridge case advancements in design might be something we might see some improvement on. Different materials for cartridge cases that allow for higher pressures and higher muzzle velocities. Maybe some different barrel technologies which can extend barrel life, and maybe limit some of the effects, the vibration effects and things like that can be negative to precision. So I think those fields are ripe opportunities as well.
Well, perfect segue into Bryan. You are the chief ballistician at Berger Bullets, and Emil, you're the business development manager for tactical sales. What has Berger got going? They are one of the leaders in precision shooting. Tell us a little bit about what you guys have going on right now.
So, on the Berger side, Bryan mentioned the kind of the tangent ogive bullet and secant ogive bullet. Well, one design that Bryan pretty much pioneered is this hybrid type of bullet, which is it has a secant nose, but where the ogive meets the riflings in the chamber or in the barrel is kind of a tangent design. So they are they're very forgiving bullets with regard to seat depth and easy to load for and easy for load development. So that's one of Berger Bullets' mainstays. And so we've got a new long-range hybrid target bullet in 25 caliber. We think 25 caliber, it's getting a lot of heat, and there's lots of, there's some new bullets out there, and much tighter twist barrels, 8 twists and such, where people were normally having very slow twists for like hunting ammunition and things like that. So we've got a new 135 grain long range hybrid target bullet, and we've got 133 grain elite hunter, both in 25 caliber. So those are brand new. We're really excited about it. And on our ammunition line, we make some of the best ammunition, factory production ammunition there is. We're introducing some 223 Remington ammunition, and the 73 grain Berger bullet, that's going to be good in 7 to 9 twist common commercial platforms, and the 77 grain load, that's for 1 and 8 twist or faster, and that's going to be kind of targeted at precision law enforcement platforms, civilian target shooting, things like that. So we're really excited to finally dip our toe in the 223 sort of premium ammunition market. So those are the two things we're working on right now that we're really excited about.
Well, I got to ask, everybody's talking about it. How are you guys in terms of supply? Because no doubt supplies are tight.
I mean, it is, and it is affecting everybody throughout the industry. We make bullets. And Berger Ammunition, we partner with some of the other companies that are part of our group, like in our like Lapua and Vitavori. So we use Vitavori propellants and Lapua cases, but primers are really the choke point, and that's for industry as well.
Yep.
So it's very difficult, and we're all struggling. And I think, there really isn't a conspiracy out there. We're making as much ammunition as we possibly can, but demand is unprecedented. It's unbelievable, the demand. I mean, everybody knows you go into your local Cabela's or Sportsman's Warehouse, and that ammo, powder, cartridge case, and primer section is picked cleaner than a prison chicken, So, but yeah, we're trying to meet demand, and we're making ammo as much as we can, and but we are struggling for components as well.
Yeah. Well, like everything, this too shall pass, and the golden days will come back again. So, gentlemen, it's been a great talk, and I want to do this again because I've got so many questions in my head that didn't get answered. So we're going to have to do this again. So I appreciate you taking the time here on the Guns Magazine podcast.
Thank you, Brent.
Yeah, good to be here.
It was fascinating talking to Bryan and Emil, and we're already in the process of scheduling another talk to get really deep into the weeds on ballistic coefficient. If our schedules all agree, you should see that in a few weeks. And with that, we hope you're enjoying the Guns Magazine podcast. Please tell all your friends, even those crazy, gloating liberals. Guns Magazine was first in the business, and we're using our decades of friendships to bring you the most interesting chats in the gun world. If you've got questions or comments about the show, please email me. That's editor@gunsmagazine.com. Make sure you don't miss out on anything by subscribing to us on your favorite podcast catcher, YouTube, and of course at gunsmagazine.com. While you're online and while you're still allowed, don't forget to check out our sister publication, American Handgunner Magazine, at americanhandgunner.com. We'd also appreciate it if you'd share a favorite episode or some kind words on your own social media. And finally, I'd like to remind you to check out our new sponsor, guys and gals who really know what they're talking about, Berger Bullets at burgerbullets.com. That's it for this episode of the Guns Magazine podcast. For the entire staff at FMG Publications, I'm Guns Magazine editor Brent Wheat. Now get out there and get shooting.